So our panelists are going to be sitting up here. First, we're going to start with Gabriella Farah from CMRE. I invite you to have a seat. He is part of some of the European underwater competitions, as well as, SASI, the Student Autonomous Underwater Competition Europe. And then that has evolved to his participation with the European Robotics Commission, European Robotics League. Marta is, I'm not sure, Marta, if you were a former competitor, but you are now at Bristol, and you are the person who is charged with working with the competition to meet some benchmark requirements that Europe is trying to accomplish. And Tom Curtin is very aware of that and working with Ivan and Alan. Yes, Alan, okay. Next, we have Charlotte George, who is from the Naval Surface Warfare Center Carderock Division, and she manages the human-powered subrace at Carderock, but she's also been a judge for us at RobotX and for RoboBoat. And finally, Vladi Japik has some experience at SASI when he was at CMRE, plenty of experience with RoboSub, RoboBoat, and now RobotX. He had a very unique role in the RobotX judging in 2016, and he can talk a little bit about that. So I am Kelly Cooper, and generally I establish the judging criteria working with Amir or Bill, our technical directors, or Felix for RoboBoat. We work very hard to try to make that fair. We work very hard to correct our mistakes in the next year once we figure out that the students have gamed it, as Patrick, I think, mentioned yesterday. And we are very serious about setting up a judging system that reflects the objectives that we have for the competition, that inspires students to do more. We have a reward system when we want to see behaviors change. So we don't necessarily change the rules. What we do is change the awards and point system. Sometimes that's effective. We want to be sure that we are not unfairly imbalancing what the students think they have to do, because, as they've told us before, well, why are we here? We're here to win. How do we win? We score the most points. What's the most effective way to score those most points? And then they leave off the very basic things that we're trying to encourage them to learn how to do. Sometimes they spend so much time trying to catch the golden ring that they fail at that and don't do anything else either, and that's a poor experience overall for the students. So we're looking at how to balance that. I'll talk more when everyone's finished. We are not going to hold ourselves to a 6-minute time slot. Likely these 4 presentations will take the entire 90 minutes. Feel free to interrupt during the presentations with questions, and then we will take the break and come back and have a full-on discussion with audience participation. All right? And with that, Gabriella, thank you.
So good morning. Thank you, Kelly, for the introduction. So my name is Gabriele Ferri, and I come from the NATO STO Center for Maritime Research and Experimentation in La Spezia, Italy. So we can say that competition can be divided into 2 big categories. That is the student competitions and the grand challenges. So the objectives of the competitions are different. For student competitions, we aim to form students and the next generation of scientists and engineers, while for the grand challenges, we raise the bar for some complex problem to solve, and we hope that someone will solve that. So our experience started from SOSI, the Student Autonomous Underwater Challenge Europe, the most important competition for underwater robotics in Europe. It started in 2006, and it was brought to the center by Vladimir in 2010. And since then, we have been organizing that to the center in our water basin. It's a sea water basin, and I've been organizing that since 2014. So it's a single domain that is underwater, but we started also to use some surface vehicle to cooperate with the underwater robots. It's considered one of the most realistic marine underwater robotic competition in the world because we are really using real sea. So it has advantages in the sense that the guys can cope with real conditions, changing lights, changing the waves and so on. But from the other side, it makes everything more complex. So it's a student competition, but it's a competition for mature students. So this experience brought us to participate in another European project, Yacht Alone. Yacht Alone is an EU-funded project and that organizes different kinds of competition. And in our case, we were the local organizer of the Yacht Alone 2015 Grand Challenge that was held in Piombino, Italy, in September 2015. It was the final competition of the project. The idea was to put together land, sea, and air robots in a scenario inspired by the Fukushima accident. It is the first world's multi-domain robotics competition. Based on what we built on this project, or the success of Yacht Alone, we were funded for another project. It's a bigger framework of competition, the European Robotics League. Marta probably will talk better about that. European Robotics League, it's a common framework for different kinds of competition, service, industry, emergency, and as a CMRE, we were the local organizer of the ERL Emergency Robots 2017, again in Piombino, in this September. So also in this case, it was a multi-domain competition. We had some tasks, and as you can see here, Here the visibility was really low. So this probably was worse than SOSI, and this makes everything very complex from the underwater point of view in terms of the optical sensor that were more or less unuseful, or at least were really hard to see the buoys and what it has to be seen. So the teams had to use heavily sonar and optical sensors and acoustic sensors. So too much. So who are the judges? The judges are usually selected as a mix of experts in the field and also, let's say, more practical guys that are very useful to assist the teams during operations and also assist to get the scoring. Usually for SOSI we have more or less 10 people, while for ERL Yacht Alone we have more people, more or less 20, because we have 3 domains, and also we have more days of competitions. From where they come essentially from university, mainly for Europe, just for logistical reasons. We have some guys coming from industry, and we have guys coming from international organizations like OES, ONR, ONRG, and EUSI. So the judges are involved in judging, clearly, during the days of competitions, but are also important for giving feedback on the rules, because we have a set of experts that gave us feedback on the rules. So the rules of SOSI are more or less mature. That is, it's a lot of years that we have been organizing SOSI, while for Yacht Alone and ERL, it was really complex to try to harmonize the rules for the different domains altogether. So we needed also some feedback from experts in robotics and some people also from end user. For instance, the director of the intervention squad in Fukushima, Mr. Kawatsuma. So just to go quickly on the differences of the scoring. So the scoring are really different in the competition on the basis of what you want to expect that the competitors should achieve. So in SOSI we have static judging or representation, we have journal paper and video, because the teams are student teams, so they have to present their work, they have to learn how to present what they've done. While in Yacht Alone and the ERL, it's more it's not very very focused on students. So we removed this part. We have just used these SAPs that are just some papers to describe what they have to do, and it was just used for team qualification. So for SOSI, the tasks in SOSI are, we can say that are macro tasks that are big tasks. For instance, you have to inspect underwater structure. So you can get partial points on the basis of what you do. That is, if you do the 75% of the inspection, you get 75% of the total amount of point. There is also some guidance on how to accomplish the tasks. That is, if you find, for instance, the black box in the basin with the sonar, you will get some points. If you find optically, you get other points. While in Yacht Alone and ERL, the idea is a little bit different. So tasks are more atomic and more specific. And in Yacht Alone 2015, we weighted the task on the basis of the importance and on an autonomy class multiplier. And there is no guidance on how to accomplish tasks. We are more oriented to a grand challenge kind of competition. So we give the problem and we wait from the teams for a solution. In ERL, we went more with on this atomic task idea, and Marta will talk about that. So you can achieve the task with 0, 1 point per task. It's not a real point, but it's an achievement. So for what concerns the judges, we started to prepare some scoring sheets for the judges that especially in ERL, that it's a complex competition. It's really important to give the judges something to be ready to judge during those days. And finally, another difference is that in SOSI, the teams can collect points over all the week, and then we have the finals. And we put in some way together the points. And this to push the students to do well also during the qualification phase. While in the other two competitions, it was more an one-day competition. Every day it was different challenge. For instance, a 2-domain or the grand challenge with 3-domain. You go there, you have your time slot, and the output of your competition is the one for the final ranking that you have. So some just points for the discussion, because there are a lot of points of the discussion on judging. So before the competition, is it important to involve the judges for the competition before the competition really starts? In my idea, yes. Because, for instance, we can set some milestones for the team to evaluate how the team's progress. We did something like that. We can do better, especially if you loan some equipment. We'll loan some AUVs to the teams, so to push the teams to come to the competition and being preparing at least to what they should do. And also it is important to involve the judges for learn and discuss rules, because they have to know the rules. That's the first point. And rules now, at least in the last competition, become to be a little bit complex. It's a big book. So it's not easy. So we have to do some synthesis on the rules, but they have also to be prepared, because all the discussions that we have also with the teams that should be involved in this phase of the discussion should be solved before the competition, because all the discussion that you have during the competition phase the competition days can ruin the atmosphere of collaboration between the teams and the organization. That's the main thing that I think we have to keep to have a successful competition. Judging. So judging clearly has to be fair, but they're not the only requirement. It has to be objective, but at the same time, it has to be meaningful in terms of representing what really a team did at sea or on the field. I think one point we should think more is to invest in some system to support judging. This year we introduced a tracking system, underwater acoustic tracking system, to try to give the judge the position of the AUVs when they were underwater. In La Spezia we have a multi-beam sonar usually to support the judges, but we should do more. Above all, because underwater usually you do not see a lot, so you need more data to be more objective as possible. And also fairness and being a meaningful judging system, how to judge a map quality. For instance, we have this is a very good map from Tom Kyle team of this year, but how can you judge a map? How good is it? If one map is better than another, how much one bed is better than another, and you have to do that in short time. So we have different approaches. You can, Marta will tell about that. We can judge functionality in a second time, not during the competition time, but if you want to give a winner during that day, you need not only to have metrics, to be prepared with metrics for instance, mapping, but also to be fast, to give a result in a couple hours, and I think it's not easy. So another crucial point is how to balance the importance of different tasks. It's clear we have tasks that are more important, and this has to be driven by what the organizer expect and what the organizers want. And above all, another important is that how to be fair in a situation in which you have, for instance, 5 buoys to find, and the teams arrive and you give that they have found 100 buoys. So what to do in that case? To use negative points, to not take into account that they are practical problems, but you have to be prepared, because in the days of the competition, everything goes in a very rush. So people arrive, and it's really, people are very stressed, more or less, at least the teams. So you have to avoid all the possible discussion that sometimes rise. So another important point is how to balance static judging and results at sea. So I think that for this we should consider if the main objective of the competition is for student competition or a sort of grand challenge. With our competition, we are in a sort with the ERL and Euratom, we are in the middle between the two ideas. So for student, clearly static judging is really important, because they are prepared to that, but we have also keep in mind that the important thing for this competition is to have results at sea. So we have in the past in SOSI some situation in which teams with a very good static judging, because the robots were really good, they did nothing at sea. So how do you behave in that case? Do you consider them in the final ranking, or you say no, just we solved the situation saying that the first 3 teams in the ranking should score at least the passing the gate task. That is the very basic, you show essentially that you can control a little bit your robot, so the step 0. And then also another point to consider, if you have to collect points over more days of the competition, or just to have the points in the finals. It's clear here there is more work for judges, because you need judges for all the week, but then you can force also teams to be more prepared during the first days of the competition, because usually what happens, that they arrive, the robots are just to be assembled, and they work there, and they arrive at sea too late. We have seen that more at sea the teams are, the better their performance. We have some clear example, like Girona. That's it. And to conclude, we have also to find an achievement between task fulfillment and functionality demonstration. One way has been run by the Euratom and ERL, and also to include benchmarking. Benchmarking is another, Marta will talk about that, it's another really big item on this discussion, because everybody has different ideas. So are the competition the right spot for benchmarking? I think yes, they are. But how? We should guarantee repeatability. But if you have just one run, it's really hard to have some statistics results. But it's a good opportunity for benchmarking, because you have gathered together many teams. You can give the same equipment to the teams. So it's a good opportunity. We should exploit more the benchmarking aspect. And do we want just a task accomplished as they can, or do we want that accomplished in a scientific proper way? That is, we should in some way drive how the team perform the task. For instance, how to define autonomy and to reward it, just to push on autonomy. That's another decision that the organizer should do. We have example of this gate that is just to go straight and turn right and enter 2 buoys. We have teams that now do that in real navigation. They see the buoys and they put in the middle. We have other teams that, at least one other team, that is one of our veteran teams, that they just measure the time to go straight and then turn left. And so they are students, so they should improve. So we should force them to change their approach over the years and not repeating always the same because they scored the points and they are happy with that. And just to conclude, there is no perfect, clearly, judging system. So it has to be fair, it has to be objective, and so on, but at least it has to respect what the organizer expects from the team and what it has to push the competition. So thank you for the attention, and let me know if you have a question.
Does anybody have any particular questions, or would you rather wait to see the entire?
Okay.
Then we'll move to Martin. Okay.
So I'm not as tall as Gabriele. So good morning, thank you for coming here. So I'm Marta Plav, and I'm going to talk in behalf of the European Robotics League. And specifically, as my colleague Gabriel has already talked a little bit about giving you some hints on what we have been doing, I will focus more on our scoring and our main objective that was going into the bench marking, and give you before a little bit of a history on how we have been reaching the point we are now. So passing the... Okay, perfect. So here we have the beginner. So the European Robotics League is a framework, a common framework for 3 different competitions: ERL emergency robots, which is emergency robots, ERL industrial robots, and ERL service robots. So where they come from, we have to go past some years. So we have 2 big European funded projects. One was Yacht Alone and Rocking for 3 years, which they come on when we decided to score teams. They have been fed from different competitions that were existing for many years. In the case of Yacht Alone, there was the emergency, what is now ERL emergency robot, was kind of fed from SOSI in the marine side, EROP in land, and then from our center of CATEC in the air. So all this experience and different type of scoring competitions were given by our partners to develop our first scoring system for Yacht Alone. So Yacht Alone was a competition for cooperation between air, land, and sea robots in a nuclear disaster scenario. So we create one scoring system that we had some static judging since OSI. We also have a different kind of scoring with points, with given different weights. And then at the same time, during these 3 years, we had a sibling that was Rocking. So Rocking was inspired by RoboCup. So I think more or less people know about RoboCup is quite of international already. And they were focused on service and in industrial robots. And in their case, because they are an indoor competition, they could develop a methodology more based on control environments, so more towards benchmarking. That is what the European Commission was trying to make us go in that direction. So during 3 years, Rocking was also developing a scoring system led by the Politecnico di Milano. And they came with what now we are going to use in what we have been using and we will keep using in ERL. So basically, they really like that kind of scoring. And for the European Robotics League, they told, well, one of the conditions is you guys, because it's a common framework, you will need to use a common method. So these 2 years that we have already been with ERL is what we have been trying to keep going with the same in service and industry, which they are a little bit ahead of what we are with emergency. But of course, our environment is far more complex because we deal with 3 different domains plus outdoors, which is an environment in which you cannot control when it comes to benchmark things. It brings a lot of complexity. So I'm going to explain now how we go into the next. Also, perfect. So as Gabriel has said, and some people say here, there's no perfect current system, and it's not good or bad. It's like what is best for what you want to achieve. So with the ERL, our main objective that has been marked by the European Commission is like you need to focus on benchmarking. And they want that to compare teams' performance, and also it's a way to track how these teams progress during either a season, so it's more or less a year, or different seasons. So it's a system of ranking more than you go one day and you win. It's like, let's see how you perform during time, and then you will go up the ladder or just stuck and never go up. And at the same time, we want ERL to create a pool of data sets for robotics community. So all these results are available. And anybody that wants to go and see how some maybe platforms or teams are performing, they can go there and see. And then one of the other things we have in mind is to design a system that is easy for referees, so it doesn't enter in a very complex environment and which you have to really train a lot people who have very specific people for that, and then try to be as objective as possible, because now we go to the next one, which is our framework in which we have local tournaments and major tournaments. So that means that external people is going to use your system. And if you make something very complex, at the end, people interpret the things in the way, and you may end up with data sets that are really not comparable. Because, so that's what you want to have a very simple robot system that people can understand and doesn't enter in a very complex understanding of the things. So we have local tournaments that can be in different parts of Europe. So any institution or company can decide to apply for a certified testbed. By now we have this one in service robots, in industrial robots we have 2, and then in emergency it just, as I said before, we come from different projects. We are still in a process of harmonization. So these 2 years we have this major tournament Gabriel was talking about, but now we have to do in a new project that is going to start in February for another 4 years. It's just to break down, that I will explain later, and then try to find test beds for emergency robots. So we have local tournaments during a season, and then we have these major tournaments that these 2 years have been in collaboration with other big events such as RoboCup or big conference, which you can allow more participation of teams. And then the local tournaments are quite small, so it's like a test bed. You will go maybe in a lab, so normally let's see between 3-5 teams maximum, and I would say the average is 3 teams. And then in these major ones, you can find even 8. When RoboCup was running, it was like 11 or 15, so it's more variable. And in the next 4 years, this major tournament is going to turn into a smart city one, in which we will have the 3 leagues at the same time. So now we come to the fun part of it. So our scoring methodology, as we use it now, we have 2 different things. One is what we call a task benchmark, and then what we call a functionality benchmark. So a task benchmark is what we want with that is to see, has the robot achieve that task? Yes or no? So it's very purpose-oriented. Like you have done it or you don't have done it. We really don't care how you have done it, as far as you do it. And for example, if we tell you detect one boy, that's a very clear thing. So we only want to see if you have detected or not, but here we don't say how. Or for example, move A to B. How you do it? Or like this, I don't care, go to A to B. So we evaluate that with a task benchmark. With a functionality benchmark, it's like how well you have done it. How perfect is your map? How much information, how good are you detecting objects? If I tell you you have to detect 10. So we divided that. As you see, you can have task benchmarks and functionalities in the sense that for mapping, you can have, for example, object recognition that we could put inside a functionality. A task could be detect one door, detect a chair, so you can have small tasks within a functionality, or just evaluate a part of like a big functionality with only maybe one task on it. So then in the scoring system that we have now for service and industrial, and we are going with emergency, is to have several tournaments during the year. So teams can go to these local tournaments and perform. And then for getting an award, they at least have to go to 2. So this is to find that they are more kind of reliable, or more building this robustness on the system. It's like you may have a bad day or a good day, but if you go to 2 tournaments, 2 bad days in a row or 2 good days in a row, maybe it's, and if you can go to more, because sometimes you may not be able to go to one for other reasons, you have more chances to go and improve. And then with emergency, we didn't took the median, but because we don't have by now local tournaments. But in service and industry, then of all your different runs, and each run has different trials, and they get the best ones, and they get the median of that, and that is your final score for the year. Our season, just to get an idea, goes from April to February of a year, and then we have awards in March, because we give them in the European Robotics Forum. So it's something that you finally award, like it's more like Formula One or the Haute Saucer that you give at the end, one of the prizes. So how we evaluate task benchmarks? We have 3 different things. One is an achievement, one is penalizing behavior, and the other one is a disqualifying behavior. So I say here achievements are what robots should do. Penalizing behavior is what they shouldn't do, and disqualifying they must not do. So when we design our scenarios or our task, it's up to us and what we want to see to define those tasks. And that's very important, because if you don't choose the right achievements, or you don't choose the right ways of penalizing or disqualifying, it can have an effect on how people perform. In the sense of choosing the disqualifying behavior, for example, in our competition, one of them was like with the aerial vehicle just to hit the wall of the building, because we didn't want that to happen, really. If you don't disqualify a team for doing that, you may find people that risk too much, and at the end you will have one. So we decide then to put it as a disqualifying behavior. But then, for example, manual interventions, it's something that you desire not to see, because I think, okay, teams, you should not be able to do that all the time. But sometimes robots get stuck in real environments, and you are not going to disqualify a team for just getting bad luck stuck. Say, okay, We allow you up to 2 manual interventions, so you get some penalization, which it doesn't take you points because we are in a yes or no. So your ranking keeps being there, but then you will have some penalization. And the same performance with no penalization will be above you in the ranking. But you will not get minus points because it's something we somehow allow. We don't want to see, but we somehow allow. So it's more or less what I have explained here of the class lowest performance. And then, of course, if you have disqualifying, you go to 0 and you start again. With this, I can show you them. What? It doesn't. Ah, okay, there. Perfect. So I can show you here. I will show you one of the evaluation sheets we use for referees, so you will get an idea of some of the achievements we choose for some tasks. And they are different depending on each of the domains we were doing. In the case of emergency, I'm not going to enter into service or industry. If somebody was interested, I can just explain later on. Because we have been, I think it's maybe what we have been working more here. So I will show you one of the evaluation sheets, and you keep it. When it comes to decide the achievements, we had the same scenario as in Yacht Alone, the nuclear disaster, with they had to look for workers, they have to look for damages, closed valves. So we went through all that and kind of review the things that we could say, okay, this is not so important, because you don't want to have a very long list of achievements with a person in a robot trying to be there like this. And so you want really to simplify what you really want to see and where you want to go. And that's the important thing, to think and see it, and also have that mentality of students like about cheating and try to do the easy thing that maybe it's not what you want to do, that they go just through the boys and see how, okay, if they do that, which achievement I could put first that would not allow to do that. Or should I put it as a penalization if you don't detect something? So it's sit, and for that we had our, oh, good. It's a driverless car. I don't know what happened. I haven't touched it. Okay. Ah, okay. Yeah, this is the evaluation. Thank you very much. So if you see here, one of, if I move there, it's okay. Well, I have the pointer, yeah. Perfect. Okay, so you can stop here. This is a functionality benchmark one. Okay, thank you. So this is a functionality benchmark one, so it's FBM. And this was vertical wall mapping. So this doesn't go with achievement, so this is really like evaluating. So this was designed by our colleagues from CATEC, which are more the experts on flying. And in that, we gathered some information for teams of mapping a wall. And they had a vertical one, and they had to give us, if I go up, it doesn't, yeah, here. So they had to give us some data logs, which we ask for this, and then a file name, txt, with all this information. So then we put it there and we calculate and we give them an index. So the index, the bigger, then the better their rank. So the functionalities is more calculated, it is post-process. So you will not do it during the competition because it's more, we did it in Yacht Alone, and our judges, they were great because they were working very late. And really, you don't want that. People come as volunteers, and you don't pay that. So I think it's not fair. We have people working until 12 a.m. in the morning. So that's why we decide to go also into these functionality benchmarks in which you post-process. So all this data is gathered during the competition, but then you have time to post-process, and you have different judges, so at least 2 different people checking the data and get the result. So this is we have vertical mapping. We also have object recognition mapping, and then the object recognition, but for the marine side too. So if can I have the TBM 1, please? And as you see, we sign them. That I will explain you later. Yeah, that one. Perfect, thank you. So here you see, this is the full one. So here we have air, land, and sea. But for judges, we gave only the air, only the sea, and only the line. So only the things they have really to check. And this, at the end, they were measuring everything into one. So for example, we have a set of achievements. There was outdoors, and the aerial robot reaches waypoints within a radius of 5. So all this we decide. It's like we want this accuracy, 5 meters, and we want that you do this in autonomous navigation. If you do it without manually, like teleoperated, it's fine. You can keep competing, but you are not going to have the tick. So it allows you to keep doing things on your way. So we are not going to, it's not like, well, if you don't reach point 1, you cannot go to point 2. It's like you can keep going your way, but you are not going to tick. So for example, here they did very well, so all. And here is ground robot. So we have the ground robot here, and here it's reached the point within a precision of 3. So here we don't put any constraint if you do it teleoperated or you do it autonomously. So we were just not interested in seeing how you do it. Why we do that is just depending on your teams you have and what you want to see. Maybe in the next one we just decide you need to do everything autonomous for ticking. But that will be the next season.
So if I understand...
Yeah.
I just wanted to make sure I understood. So if they don't complete the first one, they can still get credit for the second and the third,
Yeah.
and they just get the ticks for the ones they complete.
Yeah, so
Okay.
they have in the rule book, it says all the things you have to do in the scenario and all the achievements. So you can keep going. So it's not that it will stop you. You can keep going, and as a referee, you say, okay, you do it, not you. So what you make sure is that they do it the way you want for scoring. Because, as I said, it's, the achievement is something that they should do. If they don't do it, but they keep going on as something that you don't mind how they do it, then okay, keep going. Maybe one day you will do it autonomously, but it depends on the capabilities. You know, some teams doesn't have still the some good object recognition autonomously. So it's you see your normal teams and you see what you can ask, and others that you say, okay, now we will push the bar and we really want to see this. So all this kind of achievement is something that you can choose. As an organizer, is what you want to see and what you're going to reward. It's more based in this benchmarking standardization. So if I give you a certification, I want your robot to do this, this, and this. If you go there and perform and you don't do this, this, and this, it's like, well, yeah, it has been nice to see you, good, but I'm not going to give you the certification. So it's more or less that.
I was going to say, so it also gives you a way to balance the new teams and the more experienced teams, and both give them credit for different aspects.
Yeah.
Yeah, this goes, important thing here is that you give them a waypoint. So that waypoint, because you require accuracy of 5 meters or 3 meters there, that means that the waypoint that you give them has to be accurate. That's something in some other competitions that is avoided because the students at that point can tell you, you gave me a wrong point. Have you had anyone complain about the waypoints and latitude and longitude given to them?
The thing is, I was not in the air, but as far as I know, Fran, that was in church, I didn't have any complaint from the air. You were in the sea. I don't know if you had.
The sea did not have that, but for ground, for example.
By now, we haven't had any person complaining about that kind of accuracy. Also, in the case of aerial, here it's, for example, if you see this, the aerial deploys the first aid kit. This was decided by CATEC, and they have, it's people that do training, so they know, and they gave the waypoints, and they went with the GPS. So it's normally, this one didn't. It was
that one is easy to measure by, you just have a measuring tape from the building to that, that distance. If you have a missing worker, you can also measure how far the first aid kit. But if you tell them, arrive to this waypoint, and, that waypoint location has to be accurate. So that's what some discussion that we had before.
By now, we didn't have any complaint. It's something we need now to redo a little bit, redesign. That is one of my last slides. And then maybe it's when when we have to sit and make it more robust. That is also in my last slide, what I would explain. But yeah, I see your point in the sense that we go to benchmarking. We need to be very objective, so it needs to be the same for everybody, and being able to measure and doesn't have these kind of problems of accuracy. Or if not, you take into account these errors that can happen, and then you allow more distance, or you decide like, well, I will never be able to be fair with that, and we cannot ask for that. Then you just ask, you reach the building. So for example, it's like you say you need to reach the building. So I don't give you a waypoint. It's a building there, and if you enter, you have reached it, and that's the achievement. So I don't give you a waypoint, but I give you a location that it doesn't matter the exact coordinates, but you need to enter. So that will be my achievement. So as I said before, this is very flexible, and it depends how you want to see it and the things you encounter. Because maybe if we had a lot of complaints, then it's like, okay, guys, next season this achievement doesn't work. We need to look for another one. So it's still very lively in our. I don't think we have found still the perfect, and we need to keep working. But on the waypoints, we didn't have any problem that I know. I didn't have any of the land or air coming. Hey, we have a problem with these. Many people is now complaining, and we need to look for another solution. So, as far as I know, we didn't.
Exactly, but for surface vehicle, you can have either GPS or you can, But I'm just saying the something that is related for surface vehicle competition. You can potentially give them a GPS point, but that has to be measured very accurately.
Well, yeah. I will just go to the last one. Can I close, please, this? Okay, great. So, well, it's more or less what I have explained. So we have first raw data collection, and then a second one for processing. Then they would sit with the referees to discuss the evaluation one. So you have a discussion there where people, okay, prove that it's real, what you have detected, it's not from 2 days before. So all the discussion would be there with the raw data and that we ask for. And then, as I say, the FVMs just comes later on. So the next steps is like we are going to redo the things into urban scenarios. Then we will have to break the 3 domains into 2 domains for ERL emergency to have local tournaments. We are going also to try to reduce the number of referees because we were around 20, so it's a lot of people, a lot of logistics and very complex. And then trying to work more into this kind of reliable, robust scoring system, because if we are going to let other people to score for us without a specific training, then it needs really we need for some years to supervise that the process is robust, we have a proof check, and everybody is evaluated in more or less the same way. So, yeah, that's it. Thank you very much.
Now for something completely different.
Yeah, just like, I don't even know how to like bound how different what I'm about to talk about is. No, maybe I'll just do this. So I'm Charlotte George. I think I know most of you in the room, and I actually am an engineer at the Naval Surface Warfare Center Carderock Division, located in West Bethesda, Maryland, in the United States. So my full-time job is in research development and production, but my part-time interest is in STEM. So our facility has a couple of different programs we use. We have stuff across all different age groups and technical disciplines. We participate in Lego Robotics, in math contest, in the Sea Perch and the Sea Glide programs. And my main STEM baby is what they call it, is the human-powered international submarine races. So non-robotic, non-autonomous, totally different. So I only have like 2 or 3 slides about that today. But because of my involvement in the STEM community at my facility, I've been able to meet up with Kelly Cooper, and as she mentioned, I participated in the 2016 RoboNation series. So the RoboBoat, the RoboSub, and RobotX, and got exposure to how they're doing their judging process. So what are the human-powered submarine races? It is a mechanical hull design, propulsion system, and life support system challenge. There really is only one objective, and that's to design, build, and race a human-powered submarine, which is a wet submersible. It's not airtight. It's actually filled with water, and they breathe on scuba while they're in it, down a 100-meter-long race course. The main goal is to be the fastest person to do that. And the categories are one-man boat, two-man boat, or propeller or non-propeller. So I have a couple of pictures. I graduated from FAU in the top right corner. That's our Talon 1, so I'm biased and I apologize for that. But it's a competition that they hold every 2 years in one of our tow basins, specifically our David Taylor model basin, which is 3/4 of a mile long, 20 feet deep, really consistent, controlled environment, so we don't have the open air aspect in our competition that we have to deal with that variability. We host it at our facility, and I act as a liaison for that event, but it's actually planned and organized by a nonprofit, all-volunteer organization, the Foundation for Underwater Research and Education. And if you're in the DC area and looking to volunteer, they are always looking for those willing to help. So my job as a liaison is not necessarily to plan the event, to do the judging system, to come up with the scoring and the awards and all that stuff, but to work with the organization for every event to make sure that the event that they want to host is the event we can host at a naval facility. They are typically don't have any restrictions on contestants, so it's a really wide range of technical ability. As you can see, I think our youngest is right there. He's been there for 2 years in a row, and he helps make the fiberglass hull for their boat. But most of the teams are high school and undergraduate and graduate level. It's open to industry, but I don't think industry's participated for a couple of years now. Where? Oh, yeah. Okay. So this is the size of our event every 2 years. So we have about 200 to 300 contestants that come through every 3 years, but we have over 600 visitors to the base over the week. The competition is actually a week long, so they have all week to get their systems there, set up, pass their safety inspections, meet the judges and do all the kind of static judging things, requirements that we do have for this competition that I'll go over. But you can almost see the span of the age group not only, but like the type of hulls that we get. So that's like a wire frame with a fabric hull over it. We also have the typical fiberglass hulls, like carbon fiber. There's a lot of interest in composite materials. And then the innovation that we get it varies. It's not actually the prime driver of the event. You'll see a lot of the same thing year after year. But from new teams, new engineers, new groups, new schools. We get wild cards every once in a while. This is a high school team from New Jersey who brought an ice cream cone. It was arguably the first ice cream cone raced down the David Taylor Model Basin since its inception in 1920s. But yeah, we have 3,000 competitors. These are rough numbers from the organization. 350 teams and over 300 submarine designs that have come through this competition, which is really kind of the point. It's a lot different than a cutting-edge autonomous robotics competition where you're trying to get the contestants and the competitors to be the cutting edge and to come up with this technology that industry needs. We're kind of a STEM event mainly. Our goal is to reach out to as much as we can in all the different age groups, between the contestants themselves that come in high school that are looking to what kind of degrees can I get into, what type of education should I be going for, to the undergraduate and graduate level students who are wondering, okay, well, what am I going to do as a career? How am I going to do it and where am I going to do that? With all the spectating that happens, we bring in media. So we have like print, internet, newspaper, all of them, television. We want to actually get the younger folks who aren't competing, have them come out, experience what the testing facility is like, maybe get them introduced to programs like Sea Perch and Sea Glide, depending where they are. So we have a very simple model, and it's get contestants to come and see the facility, to compete, to be an engineer for a week, and have a good time, and then we do it 2 years later. So you'll see that when I have my one slide on judging, that it's not comparable kind of to the animals that we're talking about today of how to judge autonomy and, how to actually evaluate performance when you have a lot of specific metrics and tasks and how well you do those things. So a couple more photos. This is actually one of my favorites. This is the race course. They're around the start line, and then it's 100 meters long, and they just go straight down. We light it up for them. We have Navy divers in there for safety support. And then we have in-water judges and static judges. So there's a small team of folks who are in the basin all week, kind of observing the teams while they're actually trying the problem, when they're getting in the water, how their safety inspections are going, how they're operating as a team, are they ready to actually go when it's their turn to go, that kind of thing. But the majority of the judging actually happens in a group of about 10 folks who are subject matter experts in hull design, propulsion systems, and life support systems. And there's one other one. We have our wild cards, like we try to get our commanding officers involved. We have a previous commanding officer who's an astronaut. Like we try to get the flair in the judges so that the contestants really feel like they have something to prove to this, like, VIP panel. But they're only looking at the vehicle, so they go and do an inspection of the vehicle. They go out and talk to the team and go through what kind of the hardware list is there and how they're tackling how to be the fastest. They are required to do a presentation, and they're required to submit a design review, a design outline. So not really a journal paper, but more like a technical report of their effort. Those are all combined in one kind of rubric that the judges are given that's not transparent to the contestants. It's kind of a secret sauce, as Kelly called it earlier. That has not been a problem for this event. I think 2016, which is the one we just had the first comment post-race of how is overall performance figured out? So I think in the next 2 years, or a year and a half actually from now, that's going to be one of the things that they're tackling for this event is how much transparency do we have to give, and should we start giving them, the rubric that we use? Because the overall goal, which is, go fast and be the fastest, they give speed awards, which are really, not subjective. There's a camera timing system in the basin that we install for the race, and they just have the fastest times of the overall time of the 100-meter course, and then they have a speed gate trap, which the kids try to go their fastest in the center of the course to catch that speed gate. But that's the main objective. They do it by an overall absolute speed award for the fastest boat in all the races. Then they also do the fastest speed by category, so 1-man, 2-man, non-prop, prop. But the rest of the awards have been along for as long as I'm aware. I've only been with the race for like 7-8 years maybe. But it's decided by the judges. The only thing that they provide is the overall performance. They give the 17 characteristics that they actually go into that number, but they don't give the weighting or what the average was for all the teams, what the mean or standard deviation that they use. They just let you know who first, second, and third place was, overall performance. And they don't really have innovation. I think is relatively new, and that's based on whatever innovation technology is brought to the race, because it's not one of the primary objectives. They just kind of give out, per race what they think should be awarded. It varies from what innovative is actually measured by each race. And Best Spirit of the Races is an award that's given out by the contestants to other teams of who kind of felt like they were being the best example of how contestants should act in a race that should be fun, but also challenging and cooperative, competition, that whole thing. So I think that is it for me.
All right, hello everyone. Vladimir Đapić. I think I know, everyone in this room. I will try to add to what other panelists have said and to cover some aspects of judging that is unique, and definitely try to start something that we can discuss after the break. I have both experience from different angles for competitions, technical director and also a judge. Also, I have experienced different kinds of competition and different competitions in different parts of the world. So cultural differences, among people that organize, judge, and compete. I have worked with underwater surface and aerial robots, and now I work with self-driving cars. So, there are different goals that you want to do and accomplish both by organizing competition and how you want to achieve something and how judging relates to that. This is a unique thing that happened for me first time at RobotX 2016, and the concept of embedded judge, and that's what I want to elaborate on in this first slide. I had I was privileged to judge many competitions, but this was for me the best experience as far as judging, and I will tell you why. Most judges, as you know, are engineers, and it's very exciting to have an opportunity to learn about a system that students built, or group of people that are competing. And also you can learn about their research potential, which in this happened to me. I was embedded judge for Embry-Riddle team. You see some photos of their platform on the slide, and I will tell you about it. But the idea here, and something that, if this concept, and from the student feedback from yesterday's session, it seems that they liked other judges being embedded and myself being embedded in their team for various reasons. But the idea here is not to distract them. So you need to be careful about your quest for knowledge about their system, and trying to learn about their system and know inside of the system, but at the same time do it at an appropriate time. What is nice about RobotX, that they had a designated a person who is the one who talks to judges, which is something that is really nice, because in that case, other people can focus on other tasks. From what I see in Gabriele's presentation, there is a possibility for other competitions with number of judges to have something like this. But third point is building relationship and trust with the with the team members and advisors. That's something that is a very key point here, because at first people don't know you. You show up, you tell them a little bit about yourself, but then they open up. You start talking and doing this aspect of networking. You get to become their advocate. You get to become someone who knows their system and can, in judges' meetings, explain some additional things that they have. You can also be someone who knows if they did it by accident or they really had autonomy engine that made decisions and accomplish the task. You learn so much from the team. At that time, I was working at Speor, so we had the same boat. And we also had, as the picture up there, we had a goal to integrate aerial vehicle on top of the surface vehicle, and leaving the deck free like this was something that we have done as well. But all the nice design, how to do things, and how to tackle the equipment underneath the platform is something that I definitely learned from the team. These are the pictures that I took first day of the competition, and I immediately sent that to my technicians and engineers to consider. And we're probably gonna, or we adapted our system based on what I learned from the competing team. Passing knowledge and experience, you also pass some experience to them. So you as a judge, as an expert in the field, you pass, and when you develop some relationship and trust, they actually take that information from you and knowledge, and they benefit. Mentorship is the next point. So for this experience, which is a week-long experience, helps you tremendously to learn how to be a good mentor, what to say, when to say something, and then also I think benefits the team about that, because some teams do have faculty advisors or several faculty advisors. Some might have industry advisors, but I think if someone comes from a different angle, different experience, they also appreciate that. And I'm hoping to continue as a mentor for a RobotX team. So I think definitely that week-long experience helped me with that. The second slide focuses on documentation task and static judging, what we have as a requirement. Gabriele did talk about the difference for documentation static judging from the student competitions versus challenges, grand challenges. And the goal for that is to reduce the burden on students if we can, but at the same time send a message about what we talked about during this RobotX Forum, how important it is to know what you did and communicate about what you did, and at the same time to pass some documentation to a follow-on team to be able to have that skill set for future career. So I want to ask here, how many faculty advisors are in the room? Okay, 3 faculty advisors. And how many of you had students submit papers at this RobotX Forum? 1. Okay. Okay, the next question is, how many of you had to tie your student to the chair in order to write a paper? Okay, so all of you basically had to really put pressure on the student to even write a paper for something like this. So I want to try to start a discussion about that by making some points in this slide. So doubts about receiving receiving the documentation after the competition is over, even if you have a monetary award for that. Then the second point is the journal papers. Sometime, because they're written before the competition, explain and content of it is desired system description. And how useful is that? Because that gets logged somewhere, it's on the website, but that's not actually the system that was that competed. It was the desired system. And then versus journal papers that can have some data analysis and some lessons learned, because those type of papers would maybe be more beneficial to new teams and even teams that competed but did not score as well. And then learning, definitely importance of learning by being forced to document something while doing development. That's a big point about sending still a good message. I want to now connect the dots. First slide was to connect the dots and explain embedded judge role and potentially share that with our friends from different competitions. And then now I want to share something from the European Robotics League competition. Gabriele had this acronym there, but I want to explain a little bit more, in my opinion, what this means. Scenario application paper. Scenario application paper is a short document that students are required to write prior to competition. I want to make sure it's short, it's less burden on them. And I'll tell you what it contains. So it does have has a content to allow judges to know the teams in advance. There's specific guidance that are for that document. There's a lot of work that was put by them to define those benchmarks, to try to define things well. There are a lot of different things in the RobotX, boat and robot sub competitions that people spend time on, thinking how to, make tasks, how to evaluate that task. So this was also a part of the system that is a well-defined document that they need to present key system characteristics. So what sensors, what hardware, software, but it can be just bullets. It can be a really short document. What novel approaches? They can potentially just give you, okay, our path planner is gonna be based on paper, and here's the link to the paper. So it's just something that gives you immediately as a judge information about what approach that they're taking. And in some cases, what is novelty and difference. And then how they will tackle a specific task. So that's something that is, still provides information what they want to do. But, and then I want to say also about SAP being the skeleton for a journal paper, not the full journal paper. So it does not really require as much time. It has introduction, it has conclusion, but then the gist of it is the figures, like in normal scientific paper, figures with caption, meaning you have something you have done and that figure is described below in one sentence. And that's actually something that can tell if the team is prepared or not, because they built the robot and they went through the gate. So that's one example. It gives also information about quick facts for the robot. So one of the things that I want to throw out here and offer to people, again, the goal, reduce burden, and then also send message about the something that Gabriele also mentioned, the milestones and involvement of organization of the competition and possibly judges. Again, if judge receives a page quick sheet about the team, it's a really easy and nice thing to have. Maybe it's a lot more burden to read, 15, maybe some competitions limit to 15-page journal paper. Maybe there's no limit. Maybe you receive a 30-page journal paper that has, it's a really in-depth, manual for their system. So if you think about it, maybe we can have something, SAP version 1 with intent to participate 1 year prior, which will have some of these components. Then after that, maybe 6 months prior to the competition, you might have SAP version 2, which you add some things, meaning these figures with captions. And then you also potentially have videos of performance. So, even if they're doing underwater competition, they can have someone down, go with GoPro or stick down GoPro and film that they did. They can give you a little log file that the mission, was done by selecting a waypoint or something, or, just basic depth and heading control or something. They can be a part of that documentation prior. And then 2 weeks prior, again, these dates are just something that I had there as a list, just because there is a connection with this forum and the preparation for next year's RobotX. About 1 year prior is the forum, and then that's 2 weeks prior. Again, they give you documentation about their work, and they do that while developing. But at the same time, it's short but it's very meaningful, my opinion. Scientific, like journal paper after competition. Again, you need to tie the students to the chair, so it's very hard to enforce this after the competition, even if you get if you give them a monetary award. But potential would be for next RobotX, which is this is applicable to this competition, but potentially that 1 month after, they actually have a draft. It doesn't even have to be the final paper like of qualities that we received here, but a draft that has some lessons learned, some things that this is how we wanted to tackle a problem, but our things broke. So I think having that available, a year prior to competition, it's beneficial to other teams. So I'll conclude with that. And if you have any questions, okay, I see some questions here. Yeah, exactly. That's exactly right. That's exactly what I said there, and that's why I started by asking faculty advisors, how many of them they had, even for this event, have them, be able to do and have students write it. So it's going to be very hard. So it's not that this is a solution. This is just an idea.
Yeah, the timing of the thing is kind of difficult for trying to write a paper afterwards, because like for me in Roboboat, as soon as we finished, I had to jump straight back into senior design and continue doing that. But with this in mind, I almost wish that I would have sat down and done a paper afterwards, because I think it would have retained a lot more of what I learned throughout the competition, and reinforced it, and had something else, but I think it's actually a good idea, a really good idea, to do a paper after this thing, for the educational value of it.
Thank you. Yeah, there are a lot of teams yesterday. Not everyone was in that session, but a lot of teams had idea like this, as far as submitting after. But I don't know the answer.
I think that's an interesting proposal, and in fact, we could experiment with the timing of it, because so many of the competitors in RobotX are graduate students, and asking for a paper afterwards that is highlighted around maybe a certain performance level or something that would be eligible for a journal gives them a venue for publication, which they're going to need at some point along that process to getting their graduate degree. And we can experiment with the timing. I mean, I just like the idea of even thinking about going down this path, because we have been talking about how to evaluate their progress along the way. And so the SAP framework, it offers that, and it also supports paper development. I will tell you, in RoboSub, with 50 teams and 10-page papers, it's a lot on the judges. And what value is there in doing that? There's always value in writing something, because if you ever have a good idea as an engineer, you want to be able to communicate that. So learning how to do that, it's a good thing. But is it meaningful within the confines of the competition and judging on site before they get in the water to perform? I don't know. Yeah. So can I go back there?
Thanks. That's interesting. Before I came here, and coming a little bit from the outside, I went back and read all of the journal papers from the 2016 RobotX. And I formed the impression, before I even came and met any of you people, that there was too much, I thought, of the desired system description. There was a lot of descriptive text in there that you skim through and think, okay, that's fairly soft stuff. What I thought was missing was, how did you pick the sensor? What were the technical specifications of that particular sensor that you needed for what you wanted to do? That's an engineering exercise. And even if it was just because this was the cheapest one on the market, but did it do what you wanted it to do, what you expected? So that's one comment. The other thing that I thought, and you've outlined it there, the testing of this performance against reality or some other benchmark, or just performance specifications. I designed something that I wanted to do this, and here is the data which shows that it did it or didn't quite do it or whatever, but that technical stuff, because that's the basis of a journal paper subsequently. That's really what a journal or a conference will want to see. The system description and the competition description, and I've been thinking about this, is really, in terms of a conference, a session in a conference with some of these papers would start off, I think, by saying, well, this is the RobotX task description, and one of those lovely videos for 5 minutes introduce the session in this conference that we're talking about, and then say, and here are some of the papers, and what we would want to see there would be the performance, the data coming out, and any innovations. The innovations are important because that's what people in the journal papers and the conferences later on will want to see. So just a few thoughts to throw in.
Thanks.
Sorry, to build on what both of you have said, is actually a great idea. It also gives us, and I'm thinking from my perspective, I'm always curious to see, from a TD perspective, what are teams using? Well, how is it evolving? How are we changing the community? And is there a trend, right? So something like this, where you're capturing, even in a database here, what type of communications architecture, what type of autonomy architecture are you using? How did you select the thrusters, the sensors, things like that? If we're capturing that on and off during 5 minutes of filling out a form, right? 6 months in advance or 3 months in advance. We've got that information available. We can push that back out and allow other teams to learn from that, and basically jumpstart the next team that wants to come in, saying, here's the design philosophy, here's the approach that they took, here's why they picked this sensor, what did and didn't work on it. And that gives us a jump up for the next team. I mean, that's not directly judging related, but I feel like it helps bring the field up.
I think that the idea of the embedded judge is really good, because the embedded judge can follow the team also before the competition, following all the progress. My question is about, is an embedded judge also involved in scoring the teams, or is just, there is no difference between scoring judges and embedded judges? They are the same. That was my question.
there was no difference because of our process. We have people who observe, and all they do is document the observation. And then, along with the embedded judge, who's part of that observation, we have a judges meeting, and the judges then determine what that observation means as far as a score. That's just the process we've used. We'll get into a little bit more of that this afternoon. I don't know, Amir, do you have your score sheet from 2016 that we created for the in-water task? I don't know that I have also one for the static judging elements that are rubrics, but I wanted to talk through specifically what we're using for RobotX and how the lessons from the things that you're doing might be absorbed into our community, and how to make that happen. Whether right or wrong, we want to get an improved system. Fausto, you're the last question. Okay. Wait to say it for the, yeah.
No, just a quick comment on the paper after. One way that maybe we can motivate, besides having conferences in nice places as Sydney that people might want to apply, is maybe, and especially through the embedded judge, if they are connected with faculties, have them getting credit points for their faculty by writing a paper. You know, there's these seminars and credit points that they need to do to get their degree done. So if you can convince faculties to have a paper as part of the project or as part of the curricula, that might help getting the papers done.
Great. We'll think about how to make that happen. Margaret?